We are going to have a backup session. This is not our regular session. So we are going to discuss the introduction part for the TypeScript, before TypeScript, what you people missed out, right? So our regular session will be on Monday, and today we will discuss the backup part. So actually, in order to understand backup means first basic points what you have missed out. So many are there. I will take a backup session for the TypeScript basic levels first before starting with the TypeScript actually. In this session, we will discuss about the parts you missed out early actually. So I hope everyone is attending from the TypeScript beginning sessions. Huh? Everyone attending from the TypeScript beginning sessions. So all of you, right? TypeScript from beginning sessions you are attending. Huh? Right. So from before the TypeScript, from which topic you are attending? Can you ping me, you people? From which topic you are attending? Can you ping me? If you are here for backup, from which topic you are attending? Okay, fine. Okay. So fine. Okay. Okay. So fine. Okay. So let's keep this like this now, right? So we will in this backup session, because many people are from that point, right? We will discuss about, in the backup session, we will discuss about the architecture, right? Yeah. So we will discuss about TypeScript. So what is TypeScript and TypeScript architecture and setup environment for TypeScript. So that means starting with TypeScript. These are the points we will discuss today, so that you can start continuing in our sessions. And the other topics, if you missed out, you can go through the notes. So, and if you have any doubts, then I will clarify the doubts by conducting one more session for backup later, right? In this session, then I will give you an overview of TypeScript architecture, and how do we set up environment, and starting with TypeScript, how to do this. These parts we will discuss. So in our regular session, we are discussing about data types, working with data types and learning about the data types, right? Yeah. So technically, let's see these points. As we learned earlier, so what is TypeScript actually? TypeScript, it is an open source cross-platform language. It is an open source cross-platform language introduced by Microsoft. TypeScript is technically an open source. It is a cross-platform language introduced by Microsoft. So TypeScript was designed and developed, was designed by TypeScript, was designed by Anders Hazelberg. So Anders Hazelberg, he introduced the concept of TypeScript. So actually he developed a language. Right, called C#. Anders Hazelberg developed a language called C#. Anders Hazelberg, right? He developed a language. Called C#. He developed a language called C#. And for that language, he introduced the concept of TypeScript. He introduced the concept of TypeScript for client side actually. So technically, TypeScript is strictly superset. It is strictly superset to JavaScript. All JavaScript functions, all JavaScript library can be used in TypeScript. All JavaScript library can be used in TypeScript. Right? We discussed about that, right? Yeah. All JavaScript library can be used in TypeScript. And important, TypeScript is used for both client side and server side. Client side, server side. TypeScript is used both client side and server side for in small and large scale applications. It is used in wide range of applications. And actually, the main intention of TypeScript was to overcome the issues with JavaScript. So actually, TypeScript is strongly typed. JavaScript is not strongly typed. Strongly typed means data types, so can restrict the values. JavaScript don't have restriction for data type values. Another important is TypeScript supports complete TypeScript supports complete object-oriented programming. All object-oriented features will work. JavaScript supports object-oriented programming, but not is object-oriented programming. You can simply say that TypeScript is an object-oriented programming. JavaScript supports certain features of object-oriented programming, but it is not object-oriented programming. And another important is TypeScript supports low-level features that can directly interact with hardware services. So that means it is faster in handling devices, hardware devices, right? That means TypeScript supports low-level features. That's the reason it can directly interact with hardware services. it is faster, and it can even run in low memory. It can run in low memory. So when compared to JavaScript, TypeScript is having all these important features. That is the reason now Microsoft already internally using this TypeScript. Actually, Google Google developed a language, uh, developed a language called ETScript for ETScript for Angular. They developed a language called ETScript for Angular, but ETScript was in the beginning days, and ETScript was similar to TypeScript. Then Microsoft asked the Google team that why you are trying again a new language, because already we have that language, you can try this. And Google was very much satisfied with TypeScript because they were designing a new language similar to TypeScript, and it was already developed by Microsoft. And they don't want to waste time in designing again TypeScript. That's the reason ETScript. That's the reason they have stopped that ETScript. And now Google started implementing this TypeScript. So Angular belongs to Google, and TypeScript used by Angular belongs to Microsoft. It belongs to Microsoft, right? That's what actually, right. So generally the point is it is related to features like whatever JavaScript was unable to handle actually. That is what point is. Another specialty about TypeScript is TypeScript is completely built with TypeScript. So a language requires actually another language support to build, because majority a language uses the support of low level languages, because high level languages cannot directly interact with machines. Generally they need low level and machine code languages, right? They can handle them, but that's the reason they take the help of low level and machine code languages. Low level will translate to machine. So the point is generally Java, .NET, all other languages, whatever you know, they are built with other languages. They are usually built with other languages. So you need to build with other languages actually. So technically the point is, so they need other languages, but TypeScript is completely built with TypeScript. This means that TypeScript have the ability to interact with hardware services. That's good and great. That means entire TypeScript is designed with TypeScript. The compilers are in TypeScript. The hosting mechanism is in TypeScript. Translators are, the library is in TypeScript. Everything, entire TypeScript is built in TypeScript. How this actually TypeScript looks like, what is the basic architecture of TypeScript? See, the basic TypeScript architecture is this. So TypeScript architecture. The basic TypeScript architecture is this. So this is the TypeScript architecture. I will show you the TypeScript architecture, what actually TypeScript comprises of, right? Yeah, this is the TypeScript architecture. So what actually TypeScript comprises of, what it is actually built with. So this is the complete TypeScript architecture. So what is that, and what are these? You need to understand a basic overview about this actually. So technically, I will show you. So this I will load here, right? Yeah. So the TypeScript architecture, let's open this. Yeah. This is the basic TypeScript architecture. And in this, what options are there? We need to understand about that. Let's see. So this is the architecture. What are the components in this TypeScript architecture? You can observe that. So the components in the TypeScript architecture. You can see in the TypeScript architecture, you can observe here. So yeah, you can observe the main important components in the architecture. So we have a TypeScript core compiler. We have a TypeScript core compiler. This purpose of this core compiler is responsible for identifying the problems in the TypeScript code that you have written. That means syntactical errors, keyword errors, so and validations, all such things. Is the data type correctly defined or not? Is the data type matching or not? All these are managed by TypeScript core compiler. There will be a TypeScript core compiler. TypeScript core compiler. This TypeScript core compiler is responsible for identifying the problems in your TypeScript code. So after for that compiling and identifying the problems in your code, actually TypeScript compiler, the core compiler, takes the help of these files like core.ts. So core.ts will get the library required for TypeScript. Program.ts, it will verify the structure of your program. That means blocks are correctly defined, blocks correctly ending or not, starting point is defined or not, all such program structure. And scanner.ts, it is used for monitoring. It is responsible for monitoring the input activities. So whenever you are providing input of values, the monitoring of input values, it is done by scanner. And parser is responsible for translating one type to another type. Checker is used to verify whether the data type is the same as expected in the memory. If not, it will take help of parser to translate. Emitter is used for generating the output and all. Emitter emits the output, renders the output. So every file have a responsibility. So compiler comprises of so many files internally working. All these are TS files, means TypeScript files only. So entire TypeScript is built with TypeScript, and the core compiler is responsible for translating. The core compiler is responsible for translating the TypeScript code, compiling the TypeScript code. But now one problem is there. So the problem is nothing but the main problem here is after compiling this TypeScript code you have to run it on a browser. We have to run on a browser. Browser cannot understand your TypeScript code. Browser can understand only JavaScript. It cannot understand TypeScript. Then developers are using TypeScript to avoid the issues of JavaScript. But browsers can't understand TypeScript. Then what happens is another compiler will come to picture. That compiler is the standalone compiler. This is the standalone compiler. This standalone compiler, so the standalone compiler takes the TypeScript code. The standalone compiler takes the TypeScript code, and transcompiles into JavaScript. So that means it translates TypeScript into JavaScript. That is why we use the command TSC, right? That is a transcompiler, TypeScript transcompiler. TSC is responsible for converting the TypeScript code into JavaScript. So that is the tsc.ts, that is the transcompiler actually. So first, whether your TypeScript code is correctly written or not, it is verified by TypeScript compiler. If it is correct, if there are any problems, it will show compile time error. So after that, translating it into JavaScript, that responsibility is taken by TSC. Generally, all these days, what we are doing, we are using TSC directly. But you have to know that when you use TSC, first core compiler will execute. After that, this TSC will execute. That means TSC will pick up the core compiler automatically. So we don't need to use the core compiler. So TSC itself takes the core compiler, first verifies your code. If everything is fine, then it will convert that code into JavaScript. That's what actually. Now, the compiler that you are using will verify all the keywords, syntaxes, and coding techniques and blocks from a library. That is what language service. Language service is actually services.ts. Language service. Generally, service means what? Generally, service means a service comprises of set of factories. A factory contains collection of functions actually. A set of repository, you can say. Whatever library is required for TypeScript, it is provided by language service. That means compiler will verify your code syntaxes from this library. That means it will provide the information to the compiler. Compiler verifies and it will execute. So the repository for TypeScript is provided by whom? The repository for TypeScript is provided by language service. Language service will provide the repository. So core compiler, standalone compiler, and the language service. All the library required for TypeScript is present here, language service. What is TS server? The word server means it is responsible for hosting actually. TS server. What is TS server? TS server is nothing but loading the TypeScript program, compiling the TypeScript program, returning the output. All these activities are managed here. TS server is the location where your TypeScript program is loaded, it is compiled, it is processed, output generated, and rendered the output to the console. So the entire processing of your program happens in server. TS server is the location where the TypeScript programs are loaded, they are compiled, they are processed, output generated and sent back. So TS server, you can say that it is the host for your TypeScript. All your TypeScript programs are compiled and processed here. This is the location where it is compiling and processing the programs, right? It will take help of language service. It will use core compiler. It will use standalone compiler, and it will generate the output, everything, and sends to the client. That is what actually TS server. So these are the basic things that usually comes here. So everyone knows actually TypeScript means everyone should know about these basic things actually, right? Point. Now here, up to this part, everything looks good, great. We know about this. What is actually shim? Shim is present in many programming languages. Any programming language, actually shim, VS means Visual Studio. Visual Studio is Microsoft actually. VS shim.ts. In computer programming languages, if you came across with the word shim, Majority times you might have not heard, but people who are in architect level, they know about shims. Shim is making your program language neutral. That means your program will run on any operating system services, cross platform, independent. That means the program that you have written, it need to be cross platform, because TypeScript is cross platform. It can run on every operating system, but directly the TypeScript is not understandable to every operating system. So the TypeScript program that you have written is translated into the native of that particular operating system by using VS Shim. Actually, VS Shim. This means language neutral. So here it means it is platform neutral. That means the TypeScript that you have written, if it has to run on various operating systems, this shim plays the key role in translating it into the native code of operating system. Every operating system have its own native code, and shim translates your TypeScript into the native of operating system. That's what actually shim can do. So that means shim is responsible for making TypeScript cross-platform. Then we have two things now. A language service is there and managed language service is there. Anywhere in computer programming, you know about managed code. You have managed code and unmanaged code. Managed service means it is understandable to every operating system. Unmanaged means it is native to specific operating system. That means when you first compile TypeScript, on which operating system you compile, so it will generate the code for that operating system. So that means language service contains the information for that particular operating system. But once the shim takes the language and makes it platform independent, then there must be some library which is understandable to every platform. That library is provided by language service, managed language service. So managed language service is understandable to every operating system. Language service is not understandable to every operating system. It is only to that particular operating system on which the program is being compiled. But managed means it will be understandable to every operating system. Converting into every operating system understandable is done by shim. Then keeping the library understandable to every operating system is done by language service. VS managed language service, that is Visual Studio managed language service. That's what actually VS shim is. And editors contains information about how TypeScript can be used, debugged, compiled on any specialized editors. Editors like Visual Studio Code, Sublime, so Dreamweaver. You can even run on Eclipse, Visual Studio like softwares. So those are editors. So for editors, whatever the support is required from TypeScript, that is provided by editors. That means editors will provide all the rules and definitions for the debuggers that are running your TypeScript, right? That is editor related configuration and rules are defined here. So entire TypeScript is under the control of all these options, So we have a core compiler, standalone compiler, language service, TS server, VS shim, managed language service, and editors. This is the basic architecture of TypeScript, right? And once you know the basic architecture of TypeScript, now we need to understand how do we start with the TypeScript. For that, we need to set up environment for TypeScript, right? So this architecture, everything is present in the GitHub. The nodes related to that, everything is in the GitHub. You can go through that, right, in our repository location. Now, important is here we need to understand how do we set up environment, set up environment for TypeScript. To start with TypeScript, how do we set up the environment? For that, first you have to, what you have to do is, first you have to install Node.js on your PC, Windows PC, Mac PC, Ubuntu, any PC. You have to install Node.js because we are installing Node.js for Node.js package manager, npm. I think you haven't clearly understood about service and shim. I think Vishnu, you haven't understood correctly about service and shim. So a service means it is a repository of functions. Understood? Huh? Shim is a tool which is used for translating and compiling into platform independent code. At least now you understood. Huh? Vishnu Ranjan. Huh. Got clarity? You are clear? Shim is a tool which is used for translating into platform independent. And the library required for platform independent will be maintained in a language service. Understood? Clear? Right. So how do we install and configure here, right? You need to know about that. So install Node.js for your PC. Why? Because Node.js in your PC for a package manager npm. npm is a package managing software which is used for installing softwares, libraries required for our projects. There are so many. You can use yarn, you can use bower, you can use grunt, right? You can use NuGet, you can use ruby gems. So many are there. But npm is very popular among them. Then we will use npm, Node Package Manager. So it will be better in future also, Node Package Manager. So you can use yarn, bower, grunt, so many are there. You can use any package managers. So npm comes from Node.js. First, what you have to do is install Node.js in your computer. So to install Node.js in your computer, nodejs.org, this is the official site. I will give you the link. So this is the Node.js, official site of Node.js. Node.js, right? So this is the official website of Node.js. This is the official website of Node.js. You can get it from there. Right. This is the download link. Yeah. You can see this is the official, and this is from where you can download Node.js. You can get a Windows installer. You can get OS, other operating system services. For every platform it is providing the library, you can download it. All right. So you can download according to your bit size. You download this MSI files, so package files for your operating system. It will get a setup file. Just follow the steps. Next. That's enough, right? You can download here. No need to tell you about any installation process here because it's quite simple. You can simply follow next. It is finished. Okay. Then you have to download, and so once you do this, the next step, you have to verify. Once verify, so check. How do you check? Is from check open command prompt, and you test node-v and npm-v. So make sure that you download and install so the Node.js version. So version 10 above for Node.js. For Node.js is mandatory. So if you already have Node.js and the old version is there, overwrite it with the new version. That's fine, right? So you can check once, open the command prompt and you say node-v it will get the node version. npm-v, it will get the npm version. npm is the package manager which we need for installing various libraries. Node.js not required for us. We are looking for this package manager, but it comes with Node.js. Later, we will use Node.js in integration with server-side technology and right server-side configurations. So initially, it is ready. It is working fine. So after that, what you have to do is you have to install TypeScript for your computer, for your PC. So you have to just open the command prompt. In the command prompt, you have to type. So here we have to just execute. How do we upgrade? You just uninstall your Node.js already you installed and install to the new, right? Now, is there any problem in that? Right. So here we have the concept is how we can install TypeScript. That means we have to use npm install -g TypeScript @latest. TypeScript is enough. @latest will get you the latest release of TypeScript, right? Anyhow, by default, it gets the latest release. -g, it installs globally. Otherwise, what happens is it will install only on the particular drive. In other drives, it will not work. So that's the reason make it global on your PC by saying -g. That will install TypeScript. After installing, you can verify by using tsc-v. It will get the TypeScript version. That means you can check tsc-v. The TypeScript version 3.9.3, that is the latest version we have, right? You can install TypeScript from there. You can install TypeScript from there. npm install -g. After that, verify whether TypeScript is there or not. Once TypeScript is working fine, you download and install. You download and install Visual Studio Code. Visual Studio Code. So editor. Download and install this Visual Studio Code editor. Many people will ask like, sir, can I use Sublime? Can I use WebStorm? Professionally, any sensible developer will use the editors which are free, open source, and specially designed by the people who developed that language. We prefer that. That means TypeScript belongs to Microsoft. Then Microsoft editors can provide better support for that rather than anybody else in the world. That's the reason for developers, we don't need to say that. So you better download and install because it is open, it is free, open source, and developed by the same people who developed that language. That's the reason this is the best editor for TypeScript. Others are okay, but not, you can say, great for TypeScript because if the language belongs to those people, they will provide better upgrades to you. They will provide better support and debugging for those languages. So better use it. So Visual Studio Code is an editor provided by the people who developed TypeScript. So that's the reason we will use Visual Studio Code. You can download Visual Studio Code. This is Visual Studio Code. It is also available for all operating system services. You can download for any operating system you belong to, right? And other platforms, you can click on other platforms, you will get for other platforms, right? Yeah. And you can download this. This is the location from where you can download actually. So this is good for our TypeScript programs, editing and working with the TypeScript programs. And this is how your Visual Studio Code looks like. This is how your Visual Studio Code looks like initially. So this is the Visual Studio Code. So we are closing the folder. Yeah. So this is the Visual Studio Code editor. Visual Studio Code editor. So once you have downloaded and installed Visual Studio Code, left side, use some more things you have to do. After installing Visual Studio Code, open VS Code, Visual Studio Code, and and install support for JavaScript. So in from install support for JavaScript from custom page, from custom page. You can see on the screen there is a custom page available right side. In the custom page, you can see install support for JavaScript. You can use Visual Studio for Python, PHP, Azure, Dockers, and more. Even your Java programs also will run here actually. So, but you need to set up all the library requirement for that. It is an open source, it will work for everything. And it will have even the supports for these so Vim, Sublime, Atom, and other editors. Those key maps are also supported here. So we don't need to worry about them. So you install support for JavaScript. So that is important. After you install support for JavaScript, now go to extensions and install. In the extensions, you see left side extensions will be there. And click on extensions, and here you can install some extensions. Important extensions you need to install here is go to extensions and install VS Code icons. VS Code icons. That is for having good proper icons for files. HTML file, HTML icon, CSS file, CSS icon. To get proper icons, you better install this VS Code icons. Then TSLint. You install the package TSLint. This will download a library for TypeScript, and it will help you in TypeScript. When you are writing TypeScript programs, the keywords of TypeScript, the coding syntax for TypeScript, it will automatically help you. That will be great, good. So install that. Library support for the TypeScript means debugging support for the TypeScript. It will be helpful for you. So Visual Studio icons, TSLint. These two are important initially. You can search here in the extensions. You can search here. So VS Code icons. So you can see VS Code icons are present here. So this is VS Code icons. You install this VS Code icons. And you will find TSLint also. You install this TSLint also. This is another one you need. And after that, you can install live server. Live server we don't need now, but later for HTML it is required. When we integrate with our HTML example, if we want, then you need a live server. So you download a live server. So live server is also available. You can get that live server. So this is live server. So live server. Yeah. So a live server is available. You can get that live server. So live server already I have installed, right? This is live server. This is required to run your project, especially if you are dealing with HTML, right? It is even helpful for your PHP, JSP like programs also here. As of now, we don't need it. So because we are running everything from command prompt, we don't need that. But good, keep it ready. Later we will use whenever situation demands for that, right? You can do that. These are all the points we need to handle. Once you keep all this ready, now you can start working with your TypeScript project. So first what you have to do is you create a folder. For your programs on your computer, in your PC. So create a new folder. So demo, say my programs, something like this. So I will say my TS programs. Okay, this is the folder. And open this folder. First create that folder and open the folder in Visual Studio Code. File, open folder. You can open the folder that is in the C drive, my TS programs. That is the folder. You have to open it. And this is where you can add your files. Already I told you the process. So add a new file, that is demo.ts. TypeScript files will have extension TS. There are icons here, new file icon, you can create a new file, right? Demo.ts, write your TypeScript program here. So let, so msg string, so is equal to welcome to ts TypeScript, and console.log, and here msg. To compile and run this, you can run from command prompt, but you have a terminal here. Use control backtick. That means, or you can simply go to terminal, select new terminal. A terminal will open here. In this terminal, you can compile your programs. Directly, you can type here tsc and the program name. Program name is, so here demo.ts. It will compile. After compiling, it will generate a JavaScript file for you. And that JavaScript file is ready. Once the JavaScript file is ready, you can run the JavaScript file by using node compiler, node and demo.js JavaScript file. It will return you the output. So this is the basic approach of how we can work. You can try it from command prompt, you can try it from here, but you have to follow all these steps. Any one thing is missing in installing Node.js or installing TypeScript, you cannot handle it. So you have to follow all these steps. All the step-by-step process, how to set up, how to install, everything, you go through that. All the steps, step-by-step process, right? So this is how we can start with the TypeScript programs and work with the TypeScript programs. And later we learn about variables, data type. Now we learned about TypeScript language, variables, data types, operators and all. I hope many of you are there from the TypeScript, variables, data types and operators, data types related, because in data types we are still discussing about string types, right? Before that, TypeScript related basic is this. And web technologies means what is difference between Angular, AngularJS, React.js, Node.js, all these things we discussed in the first session of demo actually. If you missed that, no problem. When we start Angular, at that time I will explain one more time. What is Angular, what is AngularJS, what is React.js, how they are different, and what are the versions of Angular. Those all things you are going to learn when we actually start Angular, no problem. So initially we are first starting with TypeScript, with a language which is required for our Angular. That's the reason these are the basic things we have started with TypeScript. After that, I hope you are there in rest of the sessions, right? So hope you are clear. If you still miss any topics, then let me know about them. So I will conduct one more backup session. So I will let you know when the backup session will be. Then in that backup session, we can continue with them, right?